So I think we're recording. Welcome everyone to this workshop on multivariable thinking in introductory and intermediate statistics courses. Let me share my screen and show you a couple of slides. I'm going to do this without presentation mode. Well, there's the title of the workshop, Multivariable Thinking in Introductory and Intermediate Statistics Courses. We do want to acknowledge and thank the National Science Foundation for funding this workshop. There's a website which has materials related to this NSF-funded project, and we'll post that in the chat later when there's a good opportunity to do that. The goal of the workshop today and tomorrow is to provide faculty participants with ideas and activities for helping their students to develop skills of multivariable thinking. So we have 3 presenters today. We'll have 3 presenters tomorrow. Today, our presenters will be Nathan Tintle, whose academic appointment is at the University of Illinois, Chicago. Todd Swanson, who's recently retired from Hope College in Michigan. And Laura Callis, who teaches at Curry College near Boston. Tomorrow, same time, same place, we'll have 3 speakers from Cal Poly San Luis Obispo, Karen McGoy, Soma Roy, and Beth Chance. Let me talk about the format for today, which is that, well, first of all, today it's all about multivariable thinking in introductory statistics courses. Tomorrow will be a bridge to intermediate courses. And we use the word bridge there purposefully because we're not saying that tomorrow is only materials and activities for intermediate courses. Some of what you see tomorrow will be appropriate for intro courses, as well as intermediate courses or follow-up courses. Pretty much everything today will be appropriate for a typical Stat 101 introductory courses. Roughly, the schedule is we'll have sessions of about 45 minutes each, 3 of them, 1 for each presenter. We will take 10-minute breaks between sessions. If all goes well, that will leave us 15 to 20 minutes for Q&A at the end of our 3-hour block today. You should certainly feel free to type questions and comments into the chat at any time. That's one of the nice things about having multiple presenters here. Someone else can field the questions in the chat while the other person is presenting. I put that note there about recordings will be posted just to remind myself to press the record button in case I had forgotten by this point. But we will post recordings on that website that I mentioned earlier. And I will also send out an email message with a link to the recordings. So that's the schedule for today and tomorrow. That's the idea. Without further ado, let me turn it over to Nathan Tintle for our first presentation on multivariable thinking here today.
Thanks, Alan. Hello to everybody. Thanks for joining us here today. I'm just going to try to get my Zoom bars in the right spot. All right, there we go. So as Alan said, and just as a reminder, please don't hesitate to put questions or comments into the chat as we go. In fact, a couple times I'll be asking you to do that, so be ready. But one advantage of having other folks like Todd and Laura and Alan and Beth and Soma here is that sometimes they can answer questions as we go, or at least highlight things to me if I'm not seeing your questions. So don't hesitate to put stuff there. So what we're going to talk about in this first session are really sort of there's 2 parts. The first part is the what and why of multivariable thinking. And so I'm going to do a little bit of stage setting to try to get us oriented to this idea of multivariable thinking, which then we're going to unpack through the rest of the sessions today and tomorrow. And then I'll start unpacking that through something called a sources of variation diagram. And so a little bit of general sort of setup on multivariable thinking, and then a little bit of rolling up our sleeves in terms of one way we might start talking about multivariable thinking with our students. So For many years, I have taught introductory statistics, first at Hope College in Michigan, more recently at Dordt College and at Dordt University in Iowa. And now I have an academic affiliation at the University of Illinois, Chicago. That's in response to one of the chat messages that came in just to me just a second ago. But over the course of those years, I've taught lots of introductory statistics as well as the intermediate course. But I've also always had a big part of my work being acting as a practicing statistician. And so I've always enjoyed this sort of interplay, and this is what I still do now, sort of between taking what I'm doing in practice and bringing it into the classroom and vice versa. And so really this idea of multivariable thinking, which we want to talk about, we should sort of say, what is it? And so here are some potential responses to this question of what multivariable thinking is. It is recognizing that variation in some response variable can come from many, many different sources, and then being able to identify what those sources or potential sources are. It's recognizing that relationships that we discover in a statistical analysis or data visualization between two variables, so that is a response variable and an explanatory variable, depend in large part on how the study has dealt with many other variables that may influence the response. And that can happen, as is alluded to in point 3, through the way we design the study, by including certain observational units, certain people, or whatever it is we're sort of investigating in the study or not. Through the way we control them in our experimental design, if it's an experiment, or the way we analytically control for them through some sort of adjustment in a regression model. And then after sort of all of this analysis and design, the last point here is, what is multivariable thinking? It's drawing the right conclusions, the appropriate conclusions from a data analysis, understanding what our data can and can't tell us. What are the limitations of those? So in our mind, multivariable thinking really informs this entire trajectory of the statistical investigation process. I'll just say that one more time. So when we think about multivariable thinking, we're thinking about how it really informs the entire trajectory of the statistical investigation process, from the time we come up with a research question, we design the study, and we explore the data, and we analyze the data, and then we report our conclusions. So if that's sort of some of the potential what's of what variable thinking is, multivariable thinking is, then there's the question, well, why should we be doing this? And I'll flash forward, sort of rewind, I should say, not fast forward, rewind back to when I was learning this as an undergrad and graduate student. And at that time, I remember not really getting into multivariable thinking in any serious way until I got quite a ways into my undergraduate and graduate career, because the feeling was, well, you've got to have calculus. And to kind of get through, multivariable calculus things, and you've got to have probability theory, and you've got to have linear algebra to understand how to sort of, work with these big multidimensional, data sets and things like this. And once you do all that, now you're ready to do multivariable statistics. And I'm really excited about the fact that the modern view, which first got operationalized in a concrete way in the 2016 version of GAZE, is that multivariable thinking is not sort of for the few chosen people who are good enough to look at it and understand it, but really it's for everybody, because the world is multivariable. And so if we're going to really do justice to working with our students in our introductory courses and beyond, we have to recognize that the world is multivariable. And of course, we also know that big data and bigger data is important, and it's not going away. And so I do think that the big data era is forcing us into this multivariable space. But I still think there's some big questions about the why of multivariable thinking. So we say, okay, we should be doing this. It's somewhat in response to big data, but what does that actually mean? And what are the role of these quote unquote data science perspectives in our first or second courses? And then, what does this multivariable thinking mean and look like? And we started unpacking that on the previous slide, but again, that's part of our goal really over the next 2 days, is to unpack that definition of multivariable thinking more and help you think about what this could look like in your courses. So I'll just point out the Gaze guidelines. If you're not familiar with these are the guidelines for assessment and instruction in statistics education. They were first adopted by the American Statistical Association in 2005. They were revised in 2016, and they're undergoing a revision process as we speak. I'll talk more about that in just a minute. But the currently adopted guidelines, which are on the screen, you'll see that the original 2005 guidelines just said teach statistical thinking. In 2016, they unpacked that in two ways to say that statistical thinking is an entire investigative process of problem solving and decision making. I alluded to that a minute ago. And that as part of that, students should experience multivariable thinking. But you'll notice here in the guidelines that they don't really unpack what multivariable thinking is, which is why we've been trying to set the stage with you here now, and we will over the next couple of days talk about the what multivariable thinking is. And then these other guidelines are on the screen. I won't spend a ton of time with them now, but if this is new for you, I'd really encourage you to Google Gaze guidelines and go read about Gaze and understand how this can impact your teaching in your introductory and courses beyond the introductory level. So now I'll give you a little bit of sort of my thoughts on this. I think these are probably generally reflective of the speakers the next few days, but you're going to see different pedagogies and you're going to see different ways we each operationalize these in our classes. I love doing workshops with other instructors because I always learn so much from them and see their style and their way of operationalizing things. So I hope you can appreciate that too. But even in some of the things I'm about to say, I know there's some nuance and some difference even amongst us as presenters. But here's some of my thoughts. I really think we can and should be doing more with multivariable thinking in the first course. I don't think that that this course needs to ignore the fact that the world is big and multivariable. And I think too often and for too long, again, we've taken that historical view of, well, until you know enough math, until you know enough probability, you're not going to be ready to understand how complicated the world is. And I think we need to do better with that with our introductory students. I also think that related to that, a second course in statistics doesn't need to be reserved for students who've had advanced mathematics. I really encourage you to think about at your own institutions how to make your first course not a terminal course. So that is when I say the first course, I'm thinking of the algebra-based introductory statistics course. That has been the way things have been for a long time, that course is sort of viewed as a one and done, and this is the only chance we have. But as you begin to think of that course as a bridge to upper level courses, whether they're in your department, a statistics or math department, or in some other department, like a research methods class in the psych department or the biology department, this allows you to start putting strands in your first course that bridge to those second courses, which should be doing even more with multivariable thinking maybe than you're even doing in the first course. And that's really my third bullet here is, how can you be thinking in your first course about how to bridge to those second courses and beyond? And as Alan said, I just want to emphasize, even though today is primarily about the introductory course and tomorrow is about that bridge to the second course, I'm going to be trying to plant, at least in my talk, and I think Todd and Laura will do the same, seeds in about how does this bridge to that second course? So really, we're looking at this as a trajectory across a student's sort of educational experiences with statistics. Now, I'll say in bullet 4 that I don't think multivariable thinking in the first and second course necessarily means throwing students into the deep end with massive data sets. Here's a huge data set, go explore, right? Not necessarily. Maybe it does. I'm a little concerned. That makes me a little nervous sometimes because I fear that then students are going to get bogged down in data management and data manipulations, and just get overwhelmed with the sheer volume and magnitude and sort of the technical aspects of big data, as opposed to the conceptual aspects of big data. And that's really something I want to emphasize here. I do have a real fear that as we move to multivariable thinking, if we think of it as really big, massive data, as we think about data science and the impact it should have on our first course, that we overemphasize the technical at the expense, of the conceptual. And I don't want to forget that the Gaze guidelines really emphasize this need for students to be thinking conceptually in your courses, that should be what we're going after. That said, I do think we need to think carefully about how to work with messier and richer data. It's easy then to sort of fall too much in the camp of, well, then I'm going to give one small little contrived data set with a few observations and a single variable. And I don't think that's what it means either. So how can we focus on those big conceptual ideas while engaging in meaningful multivariable contexts? And I think there is a way to bridge that gap. And I think that's what we're really here to try to talk with you about over the next couple of days. And I'll just make a final comment here on this slide that I think we used to stop in the first course because we felt like we couldn't do as much. We couldn't do as much with multivariable thinking in the first course because there was so much to get in there already. And for some of you who've maybe been to some of our other workshops or familiar with some of the curricular development projects we've been part of, some of the members of this presentation team today have been part of for well over a decade now, you'll know that we've talked about the 6-step investigation process or simulation-based inference for a long time. And we feel that there are mechanisms in your first course like simulation-based inference and the 6-step statistical investigation process and other things you can do that allow you more efficiency so you don't get bogged down in the technical aspects of implementing tests of significance or confidence intervals. That you can emphasize these big overarching statistical concepts related to the way we think about data. And in doing so, that allows you time to really get into bigger, messier data sets that are going to allow you to think more about multivariable thinking. So if you're not as familiar with the 6-step statistical investigation process or simulation-based inference, just be listening for that over the next couple of days. Our presenters over the next couple of days are not going to emphasize those things, but we are going to sort of allude to them. And so I hope that you can sort of be listening for some of that. And then on the websites that we'll be sharing with you, both for this NSF-funded grant as well as some other websites we put together for other projects in the past, you can have access to more instructor resources on the 6-step investigation process and simulation-based inference. Also, feel free to put things in the chat. I see somebody did that just a minute ago, so maybe some of my co-presenters can put some links there for Elizabeth and others to go sort of dig deeper on these topics. Just briefly, the 6-step investigation process is this idea that it's really easy in our teaching to just teach statistics as compute the p-value or find the confidence interval, to say, no, it's really this entire trajectory of design, of thinking about a research question and refining it and designing a study and exploring the data and analyzing the data and reporting out. And we need to be modeling that the way we do statistics in practice. We need to be modeling that with our students in the classroom. And simulation-based inference is the idea that we can use computationally intensive methods, simulations, bootstrapping, permutations, as not just a modern way of analyzing data, even though it is, but as a way to help students understand the concept of tests of significance and confidence intervals in ways that get around some of the probabilistic scaffolding, like the central limit theorem and probability theory, that so often ended up being sort of the sticking point for students' understanding and ended up taking a lot of time in our courses. So just as a reminder, I think the things that I'm saying here are really just aligned with, or at least my intent is that these would be aligned with the GAZE guidelines. So we're going to teach thinking and conceptual understanding. We're going to make sure we're looking at real data with a context and a purpose. And the last 3 are really sort of pedagogical tools in a more concrete way. We're going to look at active learning and technology and assessment. And we'll be talking about those again kind of as we go through the next couple of days. Now, I alluded to a minute ago that the GAZE guidelines are going under a process of revision right now. Just recently, a few weeks ago, the folks who are leading that process at a national level released this website. I've got the link up there at the top, but this is just a snapshot from it. Likely these will be what the new GAZE guidelines say, the 10 recommendations are. And you'll notice number 5 is encourage multivariable thinking. So they've even pulled it out from a sub-bullet to a bullet. And again, these are preliminary. These may change a little bit. We don't anticipate that. And then likely sometime in the next, I'll say 12 to 24 months, these will be endorsed by ASA and will be sort of the new GAZE guidelines. So I don't think multivariable thinking is going away. So just as a reminder, what is multivariable thinking? Recognizing that variation in some response comes from many sources and being able to identify those. Recognizing that the relationships we discover in a statistical analysis depends in large part on how the study has dealt with many other variables. That could be through design, or we could deal with those in our analysis, or at least we could recognize those in the way we draw conclusions and understanding the limitations of those conclusions. I'll make one other sort of little broad comment here, and that is what multivariable thinking is not, because sometimes we hear this and we want to sort of get in front that, oh, multivariable thinking means I need to teach multiple regression. And while multiple regression is a great way, it's a way I use it all the time in practice. We use it all the time. We see it in publications. That's not necessarily what multivariable thinking is, right? And so I think there's a fear here that if we teach, when we hear multivariable thinking, that means teach multiple regression. That suggests that all problems are in need of inferential thinking versus just data visualization. I think you're going to see some examples over the next few days that sometimes data visualization is sufficient, or at least it should be our first step before we just jump right in and start, pushing buttons and putting more, adjusting for more variables in our multiple regression model. And it suggests that teaching a model covers all aspects of thinking. And I don't think that those two things are equivalent. A mathematical model, and there's different ways you're going to see it modeled over the next few days, another use of the word model, but you're going to see it used over the next few days, that a model is one way to help students understand multivariable thinking, but it's not the only way. It may lead also to an overemphasis on algorithmic thinking and or the technical aspects of implementation. And again, you're going to see a lot of multiple regression over the next few days. But I want to make sure you're hearing from our presenters and from me as I start talking about this a little bit more concretely in a few minutes, that the data visualization and the conceptual should really continue to be the focus as opposed to the technical aspects of how to do a multiple regression. I also think it may tend to overemphasize a single part of the statistical investigation process and really tends to de-emphasize things like study design and or the conclusions and the limitations of those conclusions. So again, just to summarize, sometimes we hear people very casually when they say, hey, you should teach multivariable thinking. So here's how I teach multiple regression. And it's almost suggesting that those are one and the same. And we just want to point out that we don't think that they are. So with that in mind, here's a first question for you. And thanks, Alan and others for posting things in the chat in response to some of the questions that have come in. I want to challenge you to answer this question in the chat and share with us what you're already doing with multivariable thinking in your first course. Because my guess is you're doing more than maybe you think you are. One of those things is confounding variables. I will say historically, over the last few decades, most introductory statistics courses have talked about confounding variables in their first course. And often that means some acknowledgement that the world is more than just one or two variables at a time, and these other variables could come in and kind of mess up our conclusions. You might also be addressing it by doing your sort of last step of a statistical investigation process, that step 6 that Soma just posted in the chat there, the look back and ahead, where you're sort of saying, hey, you know what, things are kind of complicated. There might be more to do. We don't know everything. That's also some multivariable thinking. So in the chat now, if you can answer that final question, what else are you doing in your first course to encourage multivariable thinking that you could build on in a second course or beyond? We'd love to see your answers there now. Perfect. Lots of confounding variables. Very good. Yeah, multivariable graphics and data visualizations. Wonderful. I'm going to show you an example of that here in a minute. Covariance. Excellent. Yeah, bimodal data is a great way to just sort of see the two groups, and then that pulls in a dichotomous grouping variable. And again, I'm going to show you an example of this in a scatter plot in just a few minutes. Yeah, I mean, multiple regression, and I wasn't trying to throw it under the bus. It is sort of one of the ways we think about it, and there's nothing wrong with doing that. I think more and more people are doing that in the first course. Yeah, Simpson's paradox. I think others are going to talk more explicitly about that. Interactions. Yeah, I love your point, Isabel, right? Real studies, right? Because the world is multivariable. So just by going to a real published research article or a newspaper article or something from social media or a real data set, most of the time, you're going to have to acknowledge the fact that, the world is multivariable and there's more things there. And at least if nothing else, you're just talking about it with your students, which is wonderful. Well, I'm going to jump in to an example now of one way through something called sources of variation diagrams that you can begin to talk with your introductory statistics students about multivariable thinking or set them up. And I think that we really like the sources of variation diagram because we feel like it positions students in many ways for sort of those bridge ideas that go beyond their first course. So I want to start by talking about the cost of a college education. So one of the things we like to do in our introductory statistics courses, and really all of our statistics teaching, is not start with the concept, but start with the context. And so, students likely in your class are going to be interested in or have some knowledge or opinions about the cost of college. And I'll tell you that for me, this is sort of hitting home a little bit more because my oldest son, I've got 3 boys, but my oldest is going into a senior year of high school next year and likely is going to go to college somewhere in the US next year. And so there's this question on our mind and on his mind, like how much is going to cost? And I'm going to just clarify here that this question we'll use me and my family kind of as an example, but I think you could do something similar with your students. But this question of how much does college cost, again, I think your students will have familiarity with, and we're going to sort of think about, for the purposes of the next few minutes as we unpack this, the idea of college costing being sticker price. But there's a whole lot more to that I'll come back to in a few minutes. So we're going to sort of use this question of how much does college cost? And if you're a student going into your senior year and you're thinking about that, how do you know what college is going to cost before you've maybe made your college choice? And so you might ask your student that question, or your students that question, and say, how would you unpack that? And one way would just be to say, well, what's the average sticker price of college in the US? And that might be one way to sort of guess, right? So if it's, my wife and I and my son, and we're talking about this, it's like, well, without knowing anything else about what his interests are or where he's thinking about going in the country or the kind of college or anything else, we just had to sort of guess. We might say, well, what's the average sticker price of college in the US? And that might tell us something. But pretty quickly, if you have that question with your students or ask that question with your students, they're going to probably start naturally thinking about why colleges cost different amounts of money. And this really gets into sources of variation. And so we could then ask our students, hey, you're starting to talk about why colleges cost different amounts. So what do you think some of those reasons are? Why do you think some colleges cost more than others? So you can play the role of students here for a minute. We'll use the chat again. Again, I'm talking sticker price here. What are some options that you or your students think contribute to the price of college? Why do some colleges cost more than others? All right. Public versus private. Great. Location. Acceptance rate. Yeah, these are great. Yeah, prestige. Love it. Faculty to student ratio. Yeah, how many students are there? Whether they have a football team or not. There you go. Yep, these are great. Love it. So yeah, one of the things I like about this context is that your students, again, because they are most likely, many of the places you teach in college or have gone through that undergrad process before, will have some opinions, some insights on this. So let's go a little further then with this question. We'll just go back to this idea of the best guess, not knowing anything else about my son. I should give a quick sidebar and say, I don't know either. I really like what he's going to do, what he likes. So this is actually a pretty legitimate question. I was thinking about this last night as I was finalizing these slides. Like, yeah, I really don't know. So we probably should use the best guess of what's the average sticker price of college in the US. And so the US Department of Education actually puts this data out there through their college scorecard. And maybe some of you are familiar, this is IPED stuff. I worked with our institutional research office at one of my previous institutions. So, they kind of report this stuff each year, and it goes on a website and you can download it. And one of the nice things in the world we live in today, right, is that so much data is out there and you can just go download it and play around. And I'm not going to go through all that process with you here. I want you to think carefully about if you're going to do this with your students. You know, it gets into lots of big data questions, right? When I went to this website to download the data, massively big data sets that take like more than just a split second to download. You got to find the right links. You might have to unzip things. There's a data dictionary out there. There's different years of data. How are you going to look at the data? Is it Excel? Are you going to open it up in R? Are you going to open it up in SPSS or whatever? So there's a lot of good, rich questions there. And I do think there's some appropriateness in exposing our students to those questions in a first course and certainly beyond. Go back to one of my caveats and concerns earlier. It's just not letting that become the main thing, right? Keep the main thing be multivariable thinking, statistical thinking, the concept, and not getting bogged down in the details. So I'm going to sort of keep all those details to the side here. Just wanted to plant those seeds that over the next few days, be thinking about what does this look like with your students. So I did a little bit with the 23-24 academic year data. I limited it to 2,608 institutions that had information on tuition and fees. There was some missing data there that I didn't dig deep enough to know why some places hadn't reported their tuition and fees. But the big sort of criteria I did was I only looked at institutions that were accredited by one of these 6 accreditors. So there's like, medical schools and all these kind of, like beauty schools, all these other sort of specialized places that are accredited by different agencies. So I said, I'm going to keep it to like HLC and NCCU, because I know that those are kind of the places I've been at and taught, and kind of generally the institutions that I'd be kind of curious about. It's standard undergraduate institution. As you can dig into this data yourself or have your students do it. You can use your own criteria. But when I looked at those 2,608 places, the average tuition and fees sticker price, $18,446.26 for last year. Now, the median is quite a bit smaller. Great opportunity. I'm not going to spend a ton of time with that right now to sort of talk with your students about data, and you can do the data visualization and all that. But back to our kind of research question here, which is, as a parent or as my son, the student, he's like, well, how much do you think college is going to cost next year? Not knowing anything else, we could use the mean, we could use the median. But if we use the mean of 18,000, right, we know we're going to overpredict or underpredict many of the colleges and universities in our data set. And in fact, we know also, because the median is so much small and there's a pretty skewed data set, that, the mean's maybe not a great predictor. But if we use the mean, we know that the difference between the actual tuition and fees of these 2,608 institutions and the predicted tuition, meaning the mean, is called the residual. Yeah, that was 1 year, Rachel, just to clarify. That was the year-long tuition and fees. And I also excluded some places that were not on a standard semester or quarter system. I forgot to mention that. It's down to my asterisk here, because there are some places that do like year-round stuff, and so it doesn't, the tuition and fees numbers don't map quite as nicely. So one way to start with your students on questions like this, where you're looking at the pricing of something or sort of talking about, is the mean a reasonable guess? This sort of helps you get into the idea of residual, and we're going to talk more about this on the next few slides. But if I use 18,446 as the guess, and I compute the residual for each of these 2,608 colleges and universities, you can see this dot plot. The standard deviation is $16,914. So we could guess that the price of college is going to be $18,000. If we do that and we sort of apply that to all 2,600 places in our data set, organizations in our data set, the standard deviation is around 16,900. So you might say, well, that's not a great guess. That's a lot of variation. So if my son is sort of just randomly picking one of these 2,608 places to go, that's a pretty big standard deviation on his guess. And he may want to know a little bit more, or the parent may want to know a little bit more precisely, what do we think college is going to cost next year? Now, in the chat, you all put in one of the most, I think the modal answer, at least it was the first few answers, were all about public versus private. And likely your students would say something similar. And so as we start moving to thinking about what are some sources of explained variation, let me introduce this idea of a sources of variation diagram. So this really then becomes the mechanism, the roadmap that you can work with in your students. And I love this because you can use this sources of variation diagram on pretty much every data set every context you use with students in a first course and beyond. So let's sort of fill this in. So the way this works, you sort of give students a blank diagram like this, or you put one up on the board or in your PowerPoint slides or whatever your format is, and then you work together as a group or individually to sort of fill this in. And so you start by saying, what are we observing variation in? In this case, we're looking at 2023 academic year tuition prices as reported to the Department of Education. And I only included the 2,600 or so colleges and universities that were accredited by one of those 6 main accreditation agencies for undergraduate institutions. All right. So we've observed variation in tuition prices. That's our response variable. We've limited our data set down by some inclusion criteria. And now we're going to start filling in the rest of the table. And so all that stuff you put in the chat, those are our sources of unexplained variation, because at this point, I just use the mean as my guess. I haven't dealt with any of these other things like private or public or acceptance rate or location or faculty salary or all this other stuff you all mentioned. So the sources of explained variation for now is empty. But now as we start unpacking this data set further through visualization techniques and modeling techniques, we can sort of come back to this chart and put some stuff in there. So one of the things you all mentioned was private versus public. And so if we simply stratify the data, right, and look at those two sets separately, we see a pretty big disparity. And you all probably aren't surprised by this, nor am I. And so you got the box plots there. You've got the average price in the two groups, quite a bit different. So if I asked my son, or we asked someone, well, are you going to go to a public place or a private place? That's probably not the best question to ask first, but it certainly explains a lot of variation. But we could say, well, let's use the public nature of the institution or the private nature of the institution to guess what their tuition is. And if we do that, we reduce our residuals substantially. So essentially, if for all the public schools, we use the mean public school sticker price, if for all the private schools, we use the mean private school sticker price, we reduce the residuals quite a bit. And that's what I've plotted over here. We go from around a $16,000, $17,000 sort of standard deviation in our guess down to $10,000 or $11,000. So by thinking about this in terms of residuals and guessing and making predictions about the price of school, this gets you into the idea of explaining variation and R-squared and the coefficient of determination, something we really like sort of setting the stage with students in a first course. You're probably already talking a little bit about this in terms of R-squared. Usually has always come up in my first course, but maybe didn't spend quite as much time with it. So this idea of saying, hey, you know, if we think about the residuals from just knowing whether the college was public or private compared to the standard deviation of the residuals if I just use the mean as my guess, and I take that ratio, so I've got the standard deviation of the residuals squared divided by the standard deviation of the residuals squared, comparing the model that just uses public or private, just that guess, versus the model that uses the mean, get around 40%. So that means that knowing whether the school is public or private explains about, oh, there's a typo on my slide here, apologize about that. That green number should be 60%. About 40% of the variation in, this also says home prices, which is another typo. I'll fix that. So about 40% of the variation in college tuition sticker price is explained simply by whether the school is public or private. But there's still 60% of the variation out there that's unexplained. So another variable is admission rate. Some people sort of selectivity, right? And there's different ways to quantify that. Some of you mentioned that in the chat. So this is just a quick histogram. Obviously, you do box plots or other things looking at admission rate. And so we see that, you know, many institutions are not very selective, you know, accepting over 80% of their students, but there's some that are highly selective. And going fairly quickly here, but if we also include admission rate, now I'm doing two different regression lines. So I'm doing a regression line of admission rate predicting tuition within the public schools, within the private schools. We see that we've explained more variation. So the red dots and that top line, that's our relationship in the private schools. And then the black dots with the black line, which is fairly horizontal, is for the public institutions. So our new R squared is around 57, 58%. So we've explained an additional 17% of the variation with admission rate. I know I'm going fairly quickly here, and you may not do all of this nuance in a first course, but I want you to start seeing some of the things you can do. And I will say this, I have for a long time really liked the idea of just taking a scatter plot and then doing a dichotomous variable overlay on it, like I'm showing you here in the first course, to kind of show students that, yeah, this is sort of multivariable thinking. I'm going to stratify my data into two groups, two different regression lines. This allows you to bridge to multiple regression, interaction terms. I'm showing you the R squared with the pie chart and different sources of variation. But coming back to the sources of variation diagram, we sort of now have two different sources of explained variation, the public or private institution and the acceptance rate. There's still lots more that's unexplained. And that IPED's ed.gov data has all this other information in there. Hundreds and hundreds of variables that you can explore, have your students explore, and sort of play around with, if you wish, that could potentially explain more of the variation in tuition prices. So as I've said, going from here, lots more options, more sources of variation diagram. You can talk about interactions, the lack of parallel lines in that model. You can talk about multiple regression. I just did sort of a stratification and a simple regression in each one. You can talk about the inclusion criteria. Why did I choose those 6 accrediting agencies? Should I have done more? Probably could have. Also, the nonlinearity here, the very skewed nature of the data, variable transformations and splines. I'll just go back and say, yeah, it doesn't really look to me like Align's a great fit here on the private institutions. But I mean, I did it. It's not awful. But I think for you to, again, unpack all that, should we have transformed the data, throw out some outliers? Here's an interesting place up here. Everybody gets in if you pay, I guess, at this place, right? I mean, you can talk about individual institutions. I thought, if I'm doing this with, my students another time, I might say, let's just look at like the 13 schools or the 20 schools like in our conference. Start with that and then kind of build up from there would be another way to go that might keep things multivariable, but, sort of get rid of some of the really big data things. I think in the interest of time, I'm going to skip my next one. You're going to see lots more sources of variation diagrams over the next few days. And I guess my point here with this next example is simply that this is a randomized experiment, and they work just fine for randomized experiments like they do for observational studies. And again, you'll see more of these over the next few days. So, winding down, sources of variation diagrams really can be a scaffold for that multivariable statistical thinking. It helps you lay the foundation in the first course in a way that helps you bridge to the second course and beyond. How can you control variation through inclusion criteria? And what have you explained or not explained through your data visualization or through your statistical analysis? So to conclude, I think you can use these sources of variation diagrams every day with every data set. Just like I try to do the 6-step statistical investigation process every day with every data set, sources of variation diagram, the same idea. I think this provides a strand to the upper level, just like the 6-step statistical investigation process also can continue to come back throughout your first course and beyond. I think these sources of variation diagrams help students organize their thinking. What are they trying to explain variation in? What's their response variable? What have they done to limit variation from the outset by with that inclusion criteria, by reducing down some of, eliminating some of the variability like I did with the college data, where I said, well, I'm going to throw out the beauty schools, I'm going to throw out the medical schools and all these other places. I just want to look at undergraduate focused sort of institutions. I think it also can be a lead in to more formal modeling. I didn't really go after formal multivariable modeling here with interaction terms and all that, but I was bumping right up against it. And I feel like most of what I just showed you, actually all of what I just showed you, I would absolutely do in a first course and have done in the first course to get students ready to think about more formal modeling approaches later. It also really is, I think, a natural lead in that sources of variation diagram too. I've got a response variable there on the top. My explanatory variables are the ones that are in the model, and the unexplained variation are the ones that aren't in the model. It can also lead, importantly, to more formal study design questions for both observational studies and randomized experiments, kind of getting at the inclusion criteria. But also, what are you measuring? I mentioned sticker price. I've been avoiding that this entire time. But a lot of people might say, who cares about sticker price? What about the actual price that students pay? Well, there is some information on that in the data set as well, which I ignored. And so you could talk about like, well, there's a next question. Or maybe you say, well, let's model sticker price, but let's account for discount rate. What is the average discount rate for institutions, whatever. And then how are you controlling those things in your analysis through inclusion criteria, holding them constant in the experiment or adjusting for them in your statistical model. All right, I'll stop here. And if anyone has any additional questions on what I've talked about here, I know some stuff's coming in the chat for the next couple minutes. We can do that. And then I think we'll be taking a short break after that. Any questions or comments? Yeah, so great question, Rachel. So when this session is done, I did find a couple typos on that one slide. I'll fix those. And then we're going to get these slides posted along with the data set I used that complements it on our project website. And then we'll get the link posted here in the chat as we go on. I know the other presenters will be doing similarly. So by the time the workshop's done, we'll have a full set of presentations and associated resources. I skipped the sand crabs example, but I'll put that there. We have a full worked out module for that that's ready for students. This data that I got from the education department, I'll give you my sort of mini version of it, but I've also got the hyperlink in the slides that you can just go and again just look at colleges in the Northeast or ones that are accredited by the institution that accredits your institution. I'd love to have your students find your institution in that dot plot, make it real so they make that connection between the observational unit, the dot and the dot plot, and a real college and university, and go unpack that. I didn't show you some of that, but that's really what I would encourage you to do, is maybe create your own customized version of that data set for your use.
So question about assessment in the chat. Nathan, can you talk a bit about how you assess whether students have learned what you want them to about multivariable thinking?
Yeah, it's a great question, Bernadette. It has a lot of tentacles to it. I think this is probably something you should maybe ask the other presenters as well. It's not just me getting out of answering it, but I think you'll hear lots of questions. Also something we can come back to in our bigger Q&A at the end of the day. But briefly, I think that we think about assessment, really what I would encourage you to do is when you're thinking about those tests and those quizzes, is how can you make sure the questions you're asking are conceptual? And so some of the things I'll do is I'll show graphs and pictures and have students circle things on them or respond to a data visualization I've put together or an analysis I've done. Like on that residual plot, for students say, what does one dot represent? Oh, that represents one college or university. Right. Or, I highlighted that one sort of outlier kind of up there in the upper right corner, which was a place that everybody gets in as long as you pay the $50,000 sticker price. I don't know what place that is. But, asking students those kinds of conceptual questions on your assessments, I think are really important. And it's easier to ask students, and I think bias towards technical questions, compute this value. Not that those aren't important, but just an encouragement as you think about your assessments to think more conceptually as well. Yeah, Andrew, good question. I mean, I didn't show you the dot plot of the raw data. I think if I was doing this with students, I would have done that. I was going pretty quickly there. I gave you the histogram of like the admittance rate. I think I would have preferred a dot plot there also if I was going with students, and it would have just walked through some of those things a little more slowly and carefully than what I did with all of you. Great point. Oh, good. I'm glad we all agree. Thanks, Andrew.
But if we stop there, there'll be more opportunity for a Q&A later. But thank you very much to Nathan. We have 2 more presentations to come. Let's take a 10-minute break first. It's 9 minutes till the top of the hour. Let's go until, let's say, 2 minutes after the top of the hour. I will pause the recording here. Welcome back. Our next presenter is Todd Swanson. Todd is recently retired from Hope College, but Todd stays active professionally in a couple of ways, including helping out with workshops like this. So Todd will be giving us some more ideas and examples and activities that he uses with his students or has used with his students to introduce multivariable thinking. So please take it away, Todd.
All right, hopefully you can see my shared screen.
Yep.
Yeah, as Alan said, you're interrupting my retirement with this workshop. No, this is good. Yeah, so I taught for 34 years at Hope College and retired this last year, but still have my affiliation with them. And so my tasks assigned to me was to look at association between 2 categorical variables, and then adding in that 3rd variable and talk about confounding. And you're also going to see Simpson's paradox in here as well. And then also to visualize these variables in mosaic plots. So you'll see that. And then something a little bit different, though, is adding a categorical variable to a simple linear regression model. So you'll see that at the end as well. So this first one is my main example where I'm going to spend most of the time on association and confounding. The question is, do COVID vaccines work? And the picture on there is one I took. It was probably my first vaccination, in a big area, everybody separated. And the data that we're going to look at is going to come from England in that first year of vaccinations in 2021. And just to put it in sort of a position in our curriculum, we start right off with inference, doing it for a single proportion, and then doing it for a single mean. And then along the way, we're talking about sampling distributions, and we're doing both tests of significance and confidence intervals. And then in chapter 4 is the first time we're starting to talk about 2 variables and comparing variables that way. And this would come up in that section. So as an introduction, so the pandemic started kind of in a large scale, kind of March of 2020. And amazingly, I think by December 8th of 2020, that same year, there was a 90-year-old from England who was the first person to receive a COVID vaccine shot outside of a trial. They're rolling these things out at that time. And as they rolled them out, in England, like they did here, kind of healthcare workers first, elderly first, and kind of going the age lower and lower and lower. And by June 18th of 2021, all adults in England were eligible to receive the first dose. And the second dose came anywhere from 3 to 12 weeks after that. And the vaccine was supposed to have this moderate effect on reducing the rate of infection, but it was supposed to have a much stronger effect on reducing the severity of that infection, and thus decrease the death rate. And it's the data we're going to look at is going to investigate this second point. So the data I got was Public Health England, and it's looking at all reported cases of COVID from the Delta variant, so very specific there, from February 1st, August 2nd of 2021. So in that year when things are getting rolled out with these vaccinations. And so from this, we're going to look at whether the patient was vaccinated or not, and whether the patient lived or died. And I'm going to say vaccinated in this case, to make my life a little bit simpler, is received at least 1 dose. So some of them received at 1 dose, some of them received both doses. So first question we ask a lot of times when we're going through a module with students is identify the observational units and variables in the study. Like, who are we talking about? What are we talking about that's being measured in some way? Those are the observational units. And then the variable, of course, what are we measuring on that? I'm going to make it so I can see chat. Well, maybe I can't see chat. What are the observational units? And I can't see chat.
People who received at least one vaccine.
Yeah. So, well, no, not quite. So we're going to look at people that received at least one vaccine. That's going to be one group. We're also going to be looking at the unvaccinated. So I'll just say it. I'm going to click on here and show it to you. So the observation are going to be all COVID patients that were infected with the Delta variant in England. So we're going to look at all those people that got the COVID infection from the Delta variant in England from February 1st to August 2nd, 2021. And then the variables, what we're going to look at them, were they vaccinated, that at least one dose part, and then whether or not the patient lived or died. And both of these are categorical variables and they're binary, something we talk about right at the beginning. Now I'm finding chat on a different spot here. All right, so the second question is about explanatory and responsive variables. So this is the place, like I said, that we're first getting into two variables, and then we're basically telling them what explanatory and responsive variables are. So think about what you would consider the explanatory variable in the study and what you consider the response. And so remember, our two variables we're measuring was, were they vaccinated or not? And did they live or die? And hopefully you're thinking that the vaccination status is the explanatory variable and the response is whether or not the person survived. So those are the roles. And again, let's see if I can get this chat visual. Put it over here. All right, here's the data. So again, it was all COVID patients, all people that were infected with COVID in this time frame in 2021, involving that Delta variant. So very large numbers here. And the question I have here, did a smaller proportion of the vaccinated patients die than unvaccinated? Now, the big goal of the vaccination was to reduce the severity of the infection and thus reduce the death rates. Did that in fact happen? So here I'm actually going to give you a minute and say, answer yes or no to this. Did a smaller proportion of the vaccinated patients die than the unvaccinated? Did the vaccinations help? Anybody find a calculator on your phone or somewhere you can do a little division? Here's the answer, no. No, that is not the case. That's not what happened. So no, a larger proportion, vaccinate cause death. A larger proportion of vaccinated patients died. So a very small proportion of the patients died, but it is larger for the vaccinated patients, 0.004 is the proportion, than the unvaccinated patients, 0.001. So yeah, at this point, it looks like vaccinations aren't too good. But of course, that's not the whole picture. But what I want to do with this is calculate the relative risk. So we talk about relative risk, dividing those proportions as a statistic in here. And particularly, let me go back a slide if I can, particularly when you're dealing with these tiny proportions, and I've got lots of digits there, and I can't really show that nice graphically unless it's cut off, truncated. So I think relative risk gives a nice way of comparing those two things. Difference in there certainly wouldn't give a nice way of comparing those two things. So my next question is to calculate the relative risk, dividing the proportion of deaths for those that were vaccinated, because that was the larger one. I always like the larger one divided by the smaller one, than those that were unvaccinated. And then write a sentence on it. So again, you're dividing these two numbers, that 0.004107 and the 0.001675. Anybody have a relative risk for me? Oh, one of the questions are, even without a calculator, there were fewer die out. There were fewer die out of more vaccination. Yeah, so when you're looking at the unvaccinated, is a smaller number. Oh, and I guess this is a bigger number. You always have to look at the denominators, so you can't just look at the numbers on here. But yeah, I see 2.45 in the chat. Oh, that's exactly what I got, 2.45. So that means someone that was vaccinated was about 2.5 times more likely to die than someone that was not vaccinated. And then a question we always ask about, does this seem noteworthy? Does this seem important? Or is it like, oh, that's about the same? And hopefully you're thinking, if you're talking about death, 2.5 should seem pretty noteworthy, should seem pretty important to that one. And then, as I said, we're introducing two variables at this point. So now we're introducing what associated means. So here's a definition of when two variables are associated. One variable gives you information about the value of the other one. Of course, when you're comparing two groups, you're comparing the two means, you're comparing the two proportions. And then question 5 there, do vaccination status and if someone died appear to be associated? They appear to be different enough, albeit in the wrong direction. And I'd say yes to this. And we're not doing inference in this section, but yeah, they're quite different. So causation or not. So there's two possible explanations for finding this difference that we did and this kind of odd finding. One is the vaccinations help cause more deaths, and that's why we got the bigger proportion with those who were vaccinated. The other one is the vaccinations did not cause more deaths to occur, and there's something else going on. There's something else going on, that there was a larger proportion of deaths among those who were vaccinated. In other words, there's a third variable at play here as well. And as a side there at the bottom, I said, of course, it could just be random chance, but I think we can safely rule that out. And we're not delving into that much in this section. So consider that second explanation of there's something else going on. Suggest plausible alternative variables that would help explain why those who were vaccinated were more likely to die. In other words, besides vaccination status, were those that were vaccinated different somehow than those that were not vaccinated? So put some of those answers in chat. I'm seeing older, age, older and sicker, high risk. Those who are ill, age of those vaccinated. Yeah, age seems to be coming up a lot. Pre-existing conditions. Yeah, so the vaccinated group could have been older, more likely to have chronic illnesses, other diseases. They could be less active, maybe less able to get medical help. They're in a place where they can't do that, or it's difficult to do that. All these sorts of things could have an effect. So here's the sources of variation diagram, like Nathan talked about. So we're looking at observed variation in the death from COVID. And inclusion criteria, again, it's all reported cases of COVID-19 from the Delta variant in England, February 1st, August 2nd, 2021, where the vaccination status was known. So I did throw out some people where they didn't know the vaccination status, so I'm not including those. And the sources of explained variation so far are the vaccination status, either at least one dose or not. That's what we've looked at so far. And then the sources of unexplained variation are all those other things we just listed in that previous question. So for example, age, chronic illness, other diseases, activity level, ability to obtain help. So all those things that we don't have a measure on just yet could be sources of unexplained variation. So we're going to focus on age, like a lot of you put in chat there. So in the report, they did not give the patient's age because there were hundreds of thousands of patients, of course. But they did put them in a category. They had greater than or equal to 50 years old. I'm going to call those older. And they had less than 50. So they're categorizing age into those two groups. So, and I've got in here, unvaccinated and vaccinated. And it might seem a little backwards the way I've got it. Like we always like to put explanatory variables on the top and the response in the columns here on the side. But I really want to look at how are the vaccinated and unvaccinated people different. So I want those to be my two groups. So my question here is, which group, unvaccinated or vaccinated, include a larger proportion of older people? I'll give you a hint. It's not going to be any big surprise here. I'm still going to wait for somebody to put in the chat. Which group had the larger proportion of older people? And I'm saying vaccinated. Yeah, the vaccinated ones did, of course, and by quite a bit. So the vaccinated group had that larger proportion, 27,000 by 117,000, about 23% of those were older, where the unvaccinated group, it was only about 2% were older. So the vaccinated group and the unvaccinated group, they're different, of course, because of the vaccination status, but they're also very different in terms of age. There's a lot of older people in that vaccinated group. And of course, that's going to be a confounding variable. I'm tossing in a mosaic plot here. I would have liked to toss it in at the beginning when we're looking at death rates, but the death rates were so tiny, so you're not going to see much with it. I'm going to do mosaic plots on another data set towards the end. But here's a mosaic plot on what we just calculated. So vaccination, yes or no. Those are two groups. And with this, you can see that the proportion that were vaccinated looks like it's a little smaller than the proportion that were unvaccinated because of the widths of that. If I go back here, 117,000, 151,000, yeah, it is a little bit smaller. But then, of course, what we're comparing is the proportion of old people in each group, and much higher in the vaccinated group. So those groups aren't the same for lots of things, one being age, of course. And that's when we get this confounding variable in this. So confounding variables related or associated with both the explanatory and the response in such a way that we can't separate things out. It confounds our results. And confounding of variables, of course, is why you can't draw cause and effect conclusions by association of alone. And so here's a little diagram that I always show the students. So the observational units are those COVID-19 patients. And then we looked at whether they are vaccinated or not. And then the response was they died or survived. But then we found that in the vaccinated group, you've got a lot of more older patients and a lot more younger patients in the unvaccinated group. So they're different in that way. So let's see, we already saw age is associated with vaccination status. And for age to make a difference in death rates, it must also be associated with mortality. And again, no big surprise. But sort of as an aside, I put in here, if for some reason vaccinated people were much more likely to be left-handed, but left-handedness had no effect on the death rate, left-handedness wouldn't matter. So we need to see if age and mortality are associated as well. We saw age was associated with vaccination status. Now it needs to be associated with mortality. So here's another table showing that. So again, older and younger, and whether they died or survived. So easy question. Which group, older or younger, had a higher proportion of deaths after contracting COVID? The older or the younger? Yeah, the older group. Not only is the numerator much larger, the denominator is even smaller. So the older group much more likely to die. It was about 2% of that older group died, and it was 0.003. So 3/100% of the younger group. So much more like that. So there is that strong association there as well. And then kind of putting it together for the students, explain how your answers to 8 and 9, establish that age is a confounding variable. 8 was looking at the association between vaccination status and age, and 9 was looking at it between age and death. And so because there appears to be association between age and vaccination status, as well as age and mortality, that age is a confounding variable. So we can't kind of pull that out to determine that we've got cause and effect between vaccination and or not death. But then digging a little deeper, so we have these two age groups, and the whole goal, as you know, is to, if we want to show cause and effect, we need our groups to be very, very similar right up front, and then the only one thing different. So let's sort of start looking at that or getting it closer to that. So initially we found that mortality rate was higher for those that were vaccinated than those that weren't. We also saw that we can't determine cause and effect because of confounding variables, namely age. So let's dig a little deeper into that and just look at the younger group and then just look at the older group with this. So here's just the younger group. So in the younger group, which group, the unvaccinated or the vaccinated, had a smaller proportion of deaths? Which one had the smaller proportion? I see vaccinated in there. And yeah, that's the way it was. So in the vaccinated group, 21 out of 89,000, 0.002 compared to the unvaccinated 0.003. So not a huge difference there, but it was smaller in the vaccinated group, which is the direction it should be going in. And then same thing for the older group. Which one had a smaller proportion of deaths, vaccinated or the unvaccinated? I saw both vaccinated and unvaccinated in the chat there. But we're looking at the smaller proportion of death. There was a smaller number that died in the unvaccinated group. But if we're looking at proportion, it's that vaccinated group had the smaller proportion of death. So about 1.5%, a little bit more than 1.5% compared to the unvaccinated, it was almost 6% in the vaccinated group. So smaller in the vaccinated group than the unvaccinated group. Again, going in the direction we think it should be going in the same direction as the younger group. So again, this would be introducing the students to Simpson's paradox when you have that reversal direction. So initially you found that there was a large proportion in the vaccinated group, and kind of asking them again what they just did. Is it also true when you just looked at the younger patients? Is it also true when you look just at the older patients? And the answer is no, the opposite occurred. We had that flip going on. And then that's where I'm giving them the definition of Simpson's paradox. An association or comparison holds for several groups, like the older and younger, and it's reversed when the data is merged together and looking at everyone. And another look at relative risk. Again, since we're dealing with these fairly small proportions, I think relative risk is a nice way of looking at it. So here I have calculate the relative risk of death for the younger group as well as the older group. And remember, divide the larger by the smaller one. I'm just going to give you the answers for these. So the younger group, it's 1.39. So it's not huge. For the older group, it is quite large. Yeah, somebody put in chat 3.53, yeah. And realize, you know, the older group too is 50 and above. Now I'm 50, I'm not 50, but I'm in that 50 or above category. But just think about if we could subdivide it more. It could be the 50 to 60, the 60 to 70, the 70 to 80, the 80 to 90, and how these would change, I think, probably even more and more. It'd be interesting to have the data broken down a little farther. And explain what the relative risks mean. Always have students explain things. So for the younger group, the unvaccinated were 1.39 times likely to die as the vaccinated. And for the older group, it's about 3.54 times as likely to die. They were unvaccinated compared to vaccinated. And then finally asking them basically which one of these is bigger. So which group does the vaccine seem to have the largest benefit? And of course, that's going to be the older group. And again, no surprise, we all lived through this time. We know exactly what went on with that. And then causation again. So back to that. So now based on what you found in number 12, the number 12 was looking at, listen, if you're younger, you're more likely to die. If you're unvaccinated, if you're older, you're more likely to die. If you're unvaccinated, vaccinations are helping in both groups. Can you say that vaccine is causing that reduced death rate? Do I have an answer to that? I see a no. No. Well, it's certainly an indication the vaccine will help reduce deaths. We can't conclude it's causing it. Still, we've got confounding variables. Still, this is an observational study. So at this point in our curriculum, we really haven't defined kind of yet. It's going to happen maybe at the very end of this section or the next section. Yeah. When the next section, when somebody put in chat, we do a well-designed, well-controlled experiment. That's be the next section. But no, we can't do that yet because of confounding variables are always present in these observational studies. So when can we determine or conclude causation? More specifically, how do researchers determine when a drug reduces death or drug helps decrease symptoms? And of course, the whole idea is to have two very similar groups. And then you just do one thing to one group and something else to the other group. And if that makes a difference, then it's that thing you did. And that would be explored in the very next section that we have. All right. Now shifting gears a little bit, the mosaic plot. So as I said, one of my tasks was to show you mosaic plots, and it doesn't work as well on that COVID example. So this is looking at seatbelt usage changed over time. I should mention, let me go back, way back, because there are a number of you from, whoops, where is it? Oh, never mind, that's the next section, never mind. So I have a number of you from Cal Poly. I have a picture from Cal Poly too, but that's coming up. Here's a picture of my son, who today, by the way, besides being our workshop and Prime Day, is his 27th birthday. And so that was bringing him home from college one time. And he's got a seatbelt on. And the question here is, has seatbelt usage changed over time? And how do seatbelt laws affect use and change over time? So this is results from the National Occupant Protection Use Survey. They send lots of people out with clickers on the side of the road, or just watch cars go by and they're judging, are the people wearing their seatbelt or are they not? They're clicking it, get lots of data on this. But in 2008, about 83% of the occupants, and they're looking at front seat passenger occupants, were wearing seatbelts compared to about 89% in 2018. So here's a mosaic plot for that. And the green is wearing a seatbelt, 2008, goes up to 2000 or 2018. And you can see that increase in a mosaic plot. And so we can compare that. But another question of interest, does the type of law, seatbelt law, make a difference? Some states are primary enforcement states where they can stop you and ticket you if you're not wearing a seatbelt. And some of states are secondary enforcement states where they have to stop you for some other reason. And then if you're not wearing a seatbelt, they can give you a ticket for that as well. I'm pretty sure where I am in Michigan, it used to be a secondary enforcement state, but I'm pretty sure now it's a primary enforcement state. New Hampshire, where you can live free and die, has no seatbelt enforcement law whatsoever. That's the only state that doesn't have any seatbelt law. So here's adding a third variable into a mosaic plot. And so I'm still looking at seatbelt usage in those two different years, 2008, 2018, but now adding the type of state that it's from, primary enforcement versus secondary enforcement. So when we look at, you can look at this a lot of ways. One is when you're looking at primary enforcement states in 2008 versus 2018, you can see there's a little bit of a change. It did increase from those 2 years like it did overall. And then the non-primary states, it also increased, but it looks like it increased more on that one. So the non-primary states, it looks like a large proportion were wearing their seatbelts than in 2008. But again, primary states have larger seatbelt use than non-primary states. And you can also see that where you're looking in the 2008 comparison and you're looking in the 2018 comparison. So again, that's using a mosaic plot to get at three variables. All right, my last example with doing the scatter plots. And this was the picture I was thinking of. So that's my picture of birds. And this is, I think it was the last time I was in California. We're in Pismo Beach, staying there and doing some work as a group with our SLO friends. And so I took that picture of kids chasing some gulls on the beach. So this study was looking at how do we determine the body mass of extinct birds. So these birds are extinct. We don't have their bodies. We can't weigh them. How can we determine the body mass? Well, you do have some fossil remains, and you can estimate the weight of the bones from these fossil remains, apparently. And so this was data collected in 2015, and it's got 487 birds that they were looking at, and a number of different species and repeats of a number of different species. I just kind of pulled out a subset. So I would have, like, if they had multiple American robins, I was just picking out one of those. So I'm looking at a subset of the data with 36 of these birds. And kind of like Nathan was doing in his presentation, looking at the variable of interest, the response variable we're interested in is the total weight of birds, and kind of what's the variability into that. So here's a graph of the total weight of birds, which has the mean and the standard deviation. And then the question that these researchers want to know is, can skeletal mass help explain some of this variation in there? And here I've got a regression table with skeletal mass as the explanatory variable, total mass as the response, the equations up here, and then we've got R squared. So 69.2% of the variation that we saw in total mass there can be explained by that linear association it has with skeletal mass. The regression equation does a pretty decent job of this. But then, of course, we're getting in another variable. So can adding another variable help this out? bit. So another variable the researchers looked at was the type of flight of birds. So they classified the type of flight into 4 different categories. Burst adaptive, like a quail or like a pheasant, that sort of just spends a lot of time on the ground, but when they fly, they kind of fly up straight and not very fast, and typically not very far. And then continuous flapping bird, this is a large group, like a robin. For a robin to keep flying, it's got to keep flapping its wings. It might pause them for a very short time, but not short at all. It's flapping its wings most of the time. And then the flap gliding, like a gull will do, where a gull has to flap its wings to fly, and then it can glide for a while. And gliding means you're not flapping your wings, but you're not increasing in height. You're decreasing in height for that. And then finally soaring, like a hawk will do. You see hawks circling around, and they can not flap their wings, and they can getting higher and higher and higher. So that's soaring. And so the question is, can the type of flight help explain some of that variation? So before I put it all together, I just want to look at type of flight. So here's the birds and their total mass, total body mass, and broken up into those 4 types of flight. And our R squared here, 17.2%. So 17.2% of the total variation mass can be explained by type of flight on this. And I should add at this point, so a lot of times you see R squared coming in with regression, and typically at the very end of the course. And we like to do it. I like to do it, especially much closer to the beginning. When I'm comparing 2 means, I'm talking about R squared. When I'm comparing 3 means, I'm talking about R squared. And so R squared gets used throughout the course. And so they get used to thinking about what can explain variation, kind of doing those building blocks for multivariable thinking. And then finally, here's putting it all together. So I think I had 69% of the variation in total mass can be explained by the skeletal mass. And now when I add type of flight in there, it bumps up to 81.3% of that variation. So we increase that a bit. All right. Then the last thing I want to do, still on this data set, I've got a few more minutes, is actually show you this in the applet. And I'm going to copy this, put it into chat. So this is the multivariable applet. And then I'm also going to copy the bird data. Well, I guess I can't do it that way. Well, let me try it. I had that tiny URL. This is, nope. Well, let me try it this way then. This is in a Google Sheet. So there's the Google Sheet for the birds. And on this Google Sheet, I've got the species, the common name. I'm not going to use any of those. And when I go to paste this into the applet, do not paste these 2 columns. They've got spaces in it, and that won't work well. You could paste the sex in there, male, female, but I'm gonna, in fact, I probably will do that. I'll do the sex, the flight, the total weight or total mass, and the skeletal mass. So I'm going to select this data, copy it, go to my multivariables applet. Oh, it's automatically in there. It was in there from before. Oh, here I'll add it in. Now I have the sex in there. I put that on there. And so what I was doing in my slides, I first looked at total weight, and that's going to be the response, or total mass. So there's a graph of the total mass of the birds. And then I looked at, well, does the skeletal mass help explain some of that? So I'm sliding the skeletal mass over here and getting that regression equation. I can show it here. and it's calculating R squared down here. See, sliding those things over there. And I'll take skeletal, I'll slide it back, and then I'll put the flight of the bird. I'm going to do this as the subset by. And then it has those 4 different graphs and 4 different means, as the R squared over here. And then finally putting it all together like I did. And you can click on show equations, so it shows those 4 equations. And you can see them all in the same graph, which is nice, or you can see them on different graphs. If you kind of want to look at it more closely. And I did put the sex in here, if I remember right. The sex of the bird, you know, look at that, R squared, 1.44%. Doesn't do much. So that's not, perhaps not a good variable to put into a model. But hopefully you can try that in the applet. Questions for me? Oh, one more thing, and I'm going to send this to someone. She'll post it on the website. So the main example that I went over, the COVID one, I have this in a Word document, and I will probably split off the answers. But there's a lot of verbiage, you know, talking about general association, confounding, a little more verbiage about the kind of the setup for it. Then all those questions that I went over. And there's some verbiage in between. So I did a streamlined version of this. But all the questions that I had in the PowerPoint are in here, plus a bit more. And I've got sort of some concluding remarks at the end of this. So again, that'll be posted on the website.
There was a question in the chat, Todd, about the seatbelt usage. Do you have any information on whether individual states changed the type of law they had between those 2 years you showed?
You know, I'm going to put this, like, I've forgotten more things than lots of people know. And that could be one of the things I've forgotten, because that was a while ago. And I know I've read that stuff, and and I'm sure they have, right? Between 2008, 2018, you're going to find certainly things have changed and states have changed. But yeah, I'm sure they had. And I
We also had a
don't.
question about mosaic plots and the AP statistics curriculum. And I saw that the current chief reader of AP statistics was here earlier, Barb Barnett. The question was, is AP statistics getting rid of mosaic plots in their curriculum? If you're there, Barb, in a place where you can chime in, please.
I am here. Nice to talk to you all. No, it's still in there. It's still in the AP curriculum, and we just had it on a question on this year's exam.
Thanks, Barb. We have a question in the chat, perhaps directed at Beth, about the applet. Would you recommend using the applets as the sole software for Stat 1 and or Stat 2? Todd, you can answer that if you like, or Beth could chime in. Beth has answered in the chat. Do you want to take that one, Todd, or pass?
Well, first, for Stat 1, yes, I would. I've fought off other departments wanting something else. My idea with Stat 1 is to teach them some understanding of statistics. And when you throw some software packages in there, I think that I shouldn't say deletes it. I think it turns their focus on something else. And the applets are set up to teach understanding of statistics. And most software packages are not at all to teach an understanding with it. But SAT2 is that's another question.
More questions for Todd? Feel free to unmute and ask, or ask in the chat, however you like.
There's a question about, are all those in one place? I'm thinking is that the applets question? I mean, if it is the applets question, so in stat 1, ISI applets. So we have this page for the ISI applets, categorical response, the one proportion stuff.
You want to put that address in the chat, please, Todd? Sorry for asking you to multitask.
Isn't this whole workshop on multitasking? Or was it?
Multivariabling.
Oh,
How's that verb?
yeah, and also, so they're in our textbook, the data's easily available in these pull down menus, but students can copy data and paste it in. So when students are doing projects at the end of the semester, they're collecting their own data. They're getting in, I want to say Excel spreadsheet, but that's not the case. It's a Google Sheet now. All students use the Google Sheet. And they're taking that, plopping in the applet, just like I did. So the applet can use any sort of data.
Another question for Todd.
And Beth's also adding links in there. She had the one for the stat2 link.
Yeah, but somebody didn't like the one I posted.
Oh.
How about if we pause here for our second 10-minute break? Thanks very much to Todd. It's about 11 minutes till the top of the hour. Let's take an 11-minute break until the top of the hour. Then Laura Callis will be presenting starting at the top of the hour. See you in 10, 11 minutes. Welcome back, folks. Our third presenter of the morning will be Laura Callis. Laura teaches at Curry College, which is in the greater Boston area. Laura specializes in mathematics education and teacher preparation. And in recent years, she's been teaching and studying the learning of statistics. So please take it away, Laura.
Awesome, thanks. So I'm going to use Desmos, and I'm going to put a link in the chat for everyone to go to. And I started using Desmos during the pandemic because it helps me see all of my students' responses, even if they're zooming in. And at Curry, we still have to zoom students in if they have some sort of contagious illness. So I keep using it anyway because I'm able to see students' ideas in real time, and it helps me with pacing to make sure I'm not going too fast, helps me hold students accountable. And so I thought, well, let's play with it today, see if it works in this scenario too. And if you want to learn more about how to use it, I'd be happy to help. So there's a link in the chat. If you could click on that link, that would be great. And I can see Tova's joined us and Emily M has joined us. You don't have to put in your real name if you don't want to. Bernie and Rachel and Daniel. Lots of folks. So, and I'm going to share my screen too so that I can point to things. All right. So as you can see, I can see everybody who's done a particular slide. I can see where everyone is, so that helps me with pacing if people fall behind. And then I can also click on teacher and then see what students are writing too. So I can get a quick shot of what everybody's thinking, and there's lots of math tools too. So I'm going to hop on over to the student one so that what I'm showing on my screen looks the same. So awesome. So I'm Laura Callis, and today I just wanted to share some data and activities that can be used to help students engage in multivariable thinking, particularly when we're thinking about study design. And you could use these activities in a range of courses. I use them in our Statistics 1 class, but if you're teaching like a basic math class and you're talking about percents, or if you're talking about the mean in like a liberal arts math class, you could use these activities there. And then there are plenty other studies in this area on this topic that do lend themselves to like multiple regression and much more complicated designs. So I'd be happy to talk with you if you want to talk about that, but I'm mostly talking about intro classes today. So before we start up, if you could just tell me, I feel so much pressure in September to cover all of these things for all of the different departments that our course serves, all these different tests we have to cover. Every discipline wants us to use their own software. So how do we make space for really thinking about the study design? Why is it important? Maybe just write me one sentence so I can see what folks are thinking. You might talk about why is it understanding study design important in general, or maybe how can it help you when you're teaching to sort of engage students. So write me a sentence. I'm going to look over here to see what folks are saying. This is over on slide 2. So if you could join us on slide 2 and let us know, why do you think it's worth spending time on study design when we have so many different things to talk about? Nice. And this is helping me with pacing because I see a couple of people are still typing, so I can tell when we're ready. So I see a lot of folks saying we need to know about study design so that we can actually make real conclusions, especially for students who maybe aren't going to go on and be statisticians or mathematicians. If they don't know where the data came from, then they can't make a decision about what type of analysis to do, and they also can't make a decision about the types of conclusions. I see lots of other really great ideas as well. So over on slide 3, just to echo back to Nathan's presentation, we really do think about sources of variation and multivariable thinking throughout the 6 stages or the 6 steps of the statistical investigation. Today, I'm going to really talk about the designing of a study and thinking about where the data came from, and maybe a little bit about exploring the data as well. And just to echo back again, what he had talked about is we do look for, we do sort of account for sources of variation when we think about who's going to be included in the study. We think about it too in the design of our instruments that we use to collect data, what data we collect to see if we have sort of equal groups and what potential confounding variables we need to look out for. And then also, of course, in the type of study we do. So if we're doing like within subject design, we're trying to minimize the source of variation in those person factors because we're just looking how an individual is changing over time. Or if we're doing random assignment, we're trying to make those confounding variables kind of equal in the two groups as best as we can. So lots of different ways that we deal with variation. It's not just, oh, we have interaction terms in our multiple regression model. There's lots of different things we do. So I'm going to talk today, the 3 studies we're going to look at is about the school to prison pipeline. And the school to prison pipeline is this idea in the US of students from marginalized communities are often expelled and receiving suspensions at a much higher rate than white students. And this is particularly true for African-American boys. And we can see through lots of different statistics that that actually has an impact later on. They're more likely to be incarcerated in prison, and they're also more likely to drop out of school. So this is what we're going to be taking a look at. I have a series of lessons on these because our students, after a bias incident on campus, asked the faculty to include more of these topics, more opportunities to learn about racism and sexism and all the different isms. But also I found that it engages a different group of students. They suddenly see, oh, mathematics matters. It's not just about, games of chance and how often are you going to get a 7 on 2 dice if I'm going to go play craps or something. They see that it really does matter. So just to sort of orient you to the context, take a minute to think about these different statistics and check the ones that you think are true. So I'll give folks a minute to do that. Over on slide 4, which of these do you think are true? So I can see where folks are in the slides, and I see some movements. I'm going to just wait so that folks have time to read different claims. Okay, so it looks like it's slowing down. So all of these are true, and I'll show you where to find some of these statistics. African-American students are much more likely to be suspended than white students. And what's really upsetting to me is this is true even as early as preschool. And what was really interesting to me, there's this study that looks at after some district lines were redrawn, and they were finding that even students who themselves aren't suspended or expelled going to a school with a high suspension or expulsion rate leads students to be more likely to leave high school before graduation and to be incarcerated. So it's a pretty big problem. I think that we need to address, or at least raise awareness about, and start thinking about solutions. So over on slide 5, if you could join me there. We want to sort of, so sometimes when you share your information, this will go to other students and they can see it. Here, I'm the only one that's going to see it. So anytime we start an investigation, we kind of want to just sort of think about, well, how do all of these different variables relate to each other? So why do you think that Black students are more likely to be suspended than white students? You could write a sentence for me here, or you could draw a diagram, like maybe a causation diagram over here. This is the line tool, lets you draw lines. This is the eraser button, and you can put in text here. You can change the color there. I'll give folks a minute to sort of draw your theory about why this is happening. And I'm doing this for 2 reasons. One, it helps us to make sense of the context of the study and plan our study. But also, if I'm doing this with a class and I'm going to be making groups, I want to be really thoughtful about those groups that I make, because I don't want students who might have lived this phenomenon to be with students who are still at the beginning of understanding this issue and might be doing some victim blaming. So I'm kind of like looking for, where is my class at? And what kind of ideas do they have, both intellectually, but also how could that impact how they would feel in a group with other students. So I'll give you a few minutes over on slide 5. Tell me a little bit about what you think. Why do you think this is happening? Okay, so I see that folks have lots of ideas, some of which are captured in these 3 hypotheses over on slide 6. So these 3 hypotheses are what we're going to look at. There is a ton of research literature on this going all the way back to the 90s. So because it goes back to the 90s, there are some challenging beliefs baked into that research. So you can also question some of that. And these hypotheses are also sort of present in the discourse. So if you look at like op-ed pieces or opinion pieces in newspapers, you might see some of these ideas too, and they may have data behind them in the articles or they may not. And you can kind of engage students in reading some literature and critiquing it as well. So these are some of the theories. There's lots of theories out there. One is that it's really about, which I saw some people were bringing up, that it's really about the schools, right? And that the schools are different from each other. And because the US is geographically segregated, there are more African-American students going to schools that have a higher suspension rate. And there are more white students who are going to schools that have lower suspension rates. So that could be totally true. And there's some evidence for that as well. It could be behavior. So some folks raise the idea of like, well, there's a higher rate of lead poisoning in African-American communities, which can kind of impact brain development. And so there might be more aggressive behavior among African-American students, or maybe they're experiencing more poverty or violence or trauma. So that's one theory that could be happening. Another one could be that we're going to look at is that it's teachers' perceptions. So maybe Black children and white children don't really behave any differently. Maybe it's just that teachers have an unconscious hypervigilance when teaching Black children, and they sort of expect Black children to misbehave more. And so they're watching more closely and they're interpreting Black children's behavior as misbehaving at a higher rate than white children. So we're going to take a look at these three different hypotheses. So the first thing, it's like all sorts of boxes showing up. Okay. So the first thing we're going to look at is this first hypothesis. So maybe it's just geography because we're so segregated and school policies differ so widely. So if school policies were the only driver of racial differences in suspension, and there weren't any differences in behavior, and there weren't any differences in teachers' perceptions, then if we looked at just one school, we would expect the racial makeup of students being suspended to be the same as the racial makeup of the whole school, right? If students aren't behaving any differently and teachers aren't interpreting behavior any differently, then we would expect that the group of students who are getting suspended to look pretty much like the entire school. So I have data from Brockton High School. I picked it because it's a very, very large high school near me. It's south of the town I live in. And in 2017, 2018, there were 539 students that were suspended. There's 4,123 students that attend the school. So this down here in the table, this is the makeup of the Brockton High School population, the demographics. And if we think that the differences are really just due to some sort of school factors, and within a school, the rates are the same for suspension rates, how many students do you think in each racial category would be suspended? So if you're doing this in a basic math class, it would be an opportunity to talk about percents. But I found even in my statistics 1 classes, they kind of need to think about how we would think like the subset would mirror the larger population. And the nice thing about Desmos is you can turn on this feature and it'll do the math for you if you want. So you can do 0.026 times 539 and it will calculate, or you can even use words, which is cool, 2.6%. It populates of 539. So take a minute to complete that table so that I know you kind of get what's going on here. If the students, if the behavior isn't different, teachers' perceptions aren't different, how many students in each racial category would you expect to be suspended? So this is over. This is over on slide 7. I'll give folks a minute to fill that out so I can tell that you kind of get the gist of our hypothesis. And so when you've made a prediction, this is like James Lang's small teaching, right? Have students make a prediction, even if they're wrong. We know that they remember more if they've made a prediction first. Once you've made your prediction, hop on over to slide 8, the next slide. and compare your prediction to the actual numbers. So these are the numbers of students who are suspended in each racial category during 2017 to 2018 academic year. And this is the percent. So 61, for instance, is 11.3% of 539. So what do you notice? What do you wonder? How does this compare to your previous predictions? And how do you think this impacts our hypothesis about the differing school policies being the sole driver of differences in suspension rates? So over on slide 8, tell me what you think. So I still see folks typing, so I'm going to give them a little more time to get their thoughts down. Okay, it looks like the typing slowed down. So one of the things I notice and wonder about is that, you know, Black students make up less than 2/3 of the whole student population, yet they're more than 3/4 of the suspended students, right? So that doesn't seem quite right. It seems like there must be something going on other than just school policies. Something else is happening. And then white students make up 18% of the population at Brockton, but only 11% of the students who have been suspended. So this is kind of something that I'm wondering about, and I'd like to collect more data on. So you can modify this task. This is the link to the Civil Rights Data Collection site. This is a quick little video I made just for my students on how to use the site. And so students could look up their own high school, or they could look up, if they're parents, they could look up the high school in their area. You can also get preschool data on here. You can cut the data by disability, you can cut it by gender, you can look at changes over time. There's lots of different things you can do. You could add in simulation-based inference. I have a little picture down here that walks you through how to do that. Or you could use theory-based inference. There's lots of other things that you could do just starting with this data. So let's skip over to, so I'm gonna talk this slide through so that we have time for the other studies. But in this particular study, we were thinking about the different sources of variation, right, for suspension rates. So if I was going to fill out that sources of variation diagram that Nathan showed us earlier, what we're looking for is the observed variation in suspension, whether students are suspended or not. And we only looked at Brockton High School students in 2017, 2018. And we did that because we wanted to limit the variation that might be coming from school factors. So from different school policies regarding suspension, for instance. We have one source of explained variation, which is race. So I can better predict if a student is going to be suspended or not at Brockton High School if I know their race. But there's lots and lots of sources of unexplained variation, which is why we can't make any causal claims, right? We don't know about the infraction type. We don't know about the behavior or the student's behavior history. So someone brought up this idea of lead poisoning. Maybe that could be contributing to different behavior patterns, right? We don't know. We also don't know anything about teachers' perceptions. We also don't know anything about teachers' skills at behavior management and teaching. So I know from working in schools, and this is, is true at a lot of schools, that the veteran teachers are given like the AP classes and the honors classes, right? And those classes, unfortunately, plenty of data on this, tend to be more white, whereas the non-advanced classes are usually given to the newer teachers, and those tend to be a higher percentage of African-American students. And so it might just be that the teacher's skill and behavior management is different between classes within the school, and those classes are also different demographically. So there's lots of different variables that we don't know. So let's take a look at those next. And so you can imagine too, if you were doing an intermediate investigation, there's lots of different kinds of modeling you could do. So our other two, this is over on slide 12, our other two hypotheses were that it could be the student's behavior or it could be teachers' perceptions of students' behavior. So the previous study was an observational study. There's lots of potential confounding variables that we're not accounting for. We only really tried to control for school level factors. This next investigation is also an observational study, but it accounts for additional variables in the design. So there were 132 teachers in this study, and they watched a video of 4 preschool children playing. There was a black boy, a black girl, a white boy, and a white girl. And the teachers knew that this study was about teachers' perception of behavior, but they didn't know that it had anything to do with race. And in fact, the researchers asked follow-up questions to sort of detect later if the teachers thought that the study was about race, and they removed that data. There was no, researchers then asked the teachers which child they were most concerned about in regards of behavior, and the teachers would pick one of the 4 children. There's no misbehavior evident in the video. That's really important. So thinking about this study, what sources of variation is the design of this study kind of accounting for, and how are they sort of doing that? So hop on over to slide 12 and maybe write a sentence or two. How is this particular study, the video study, trying to account for different sources of variation in its design? So hop on over to slide 12. Yeah, okay. So I see folks are still typing, and lots of folks are saying a couple of things. So they're trying to account for race and gender, right? By collecting data on by having that as part of their study design of the students. So those are kind of those explained variation places. And then we're also trying to control for, through the design of the instrument, the behavior, right? So there's no behavior differences between the children. So we know that that can't be a possible source of variation. So in this way, even though it's not an experiment, we're still trying to address this idea of like, how can we sort of capture different sources of variation and hold them constant? Okay. So let's make a prediction, James Lang again. If there really is no difference in how teachers perceive student behavior by race or gender, and this is over on slide 13, what % of the teachers would you expect to pick each child? So you can fill out that table right there. You can write a sentence if you want, explaining your thinking. But over on slide 13, if there's no difference in how teachers perceive the student's behavior due to race or gender, what % of the teachers would you expect to pick each child? Okay. All right. So I see that most folks are saying that, well, if there's no difference, we'd expect teachers are pretty much just like randomly picking one of the 4 children, right? And so we'd think that the teachers would all sort of pick, they'd be split in how they pick the different children. Maybe there'd be a little bit of difference, right? Because it would be like a random phenomenon. So maybe it would be like 23 and 24. That wouldn't really surprise us very much. But we think that pretty much all the distribution would be kind of uniform across if there was no impact of race or gender. So over on slide 14, we have the actual results. I've cut the data both just by race and then by race and gender because my students did this, which I thought was really surprising. So if we look at race and gender, it's pretty clear that African-American boys, teachers are more concerned about their behavior, even though there was no misbehavior in the video. But if we didn't consider gender, and we were only looking at race, these two percentages are really so close to each other. If you did bother doing a statistical test, they would be identical to each other. Not identical, there'd be no statistical significance. Unless we look at those interactions and intersectionality, the students will use that word from sociology, then we're not actually seeing the phenomenon. So that's one thing to think about. This is another type of multivariable thinking is let's look at the data and think about the different variables that could be at play. Okay, so over on slide 15, this is the third study, and this is an experiment, a randomized experiment. So our third hypothesis was that it's the teacher's perception. Some people said like an unconscious bias, or maybe it's just like a hypervigilance or something like that. So this study, it's called the 2 strikes study. There were 53 teachers. And the study used vignettes, so it used written vignettes. If you want to read them in detail, you can click on that link right there. Both vignettes were about one student. One of the vignettes was about engaging in insubordination, so not doing what the teacher told you to do. In this case, he had his head on his desk and he wasn't doing his work. The other one was about a student creating a disturbance. So he would get up and walk around the room and go sharpen his pencil, get a tissue, and not sit down. Half of the teachers were randomly assigned to vignettes that used an African-American sounding name like Darnell or Deshaun. And then the rest of the teachers, they read vignettes that were word for word identical, except that the name was a white sounding name like Jake or Greg. And then after each vignette, there were 2 vignettes that each teacher read, the teachers were asked to what degree they were troubled by a student's behavior, to what degree they'd recommend a disciplinary action, and whether they thought the student was a troublemaker. And they answered those questions on a scale from 1 to 5, with 5 being, I feel this very strongly. So let's just take a minute to thinking about the design of this study. What sources of variation is this study design trying to account for? And in particular, the random assignment, what is that trying to account for? So I'll give you a minute to think, maybe jot down some notes over on slide 15. Awesome. So I see the typing is slowing down. So I was seeing Felicia saying that by randomly assigning the teachers, we're hoping that sources of variation like the teacher's gender or race or age or their geographic location are kind of being balanced between the 2 groups. And then Tova has said a similar thing. And then other folks are saying that because Kari is saying that because the vignettes are the same for the different students, we know that the behavior is the same, right? So it can't be that the variation in the teacher's responses is due to differences in the behavior because the behavior is the same in the two different vignettes. So I agree with those ideas. And this is how I would draw a diagram, the sources of variation diagram. So we're looking for observed variation in the troublemaker score by the teachers, and whether they would recommend disciplinary action, and in whether they felt troubled by the behavior. And this is over on slide 16. I have it written out. The inclusion criteria is 53 female teachers from the last month of the academic year. And the design was a randomized experiment using vignettes. And the vignettes, as I think Kari said, were helping to address variables like the infraction type, right? So they had the same type of misbehavior. And maybe a vignette study can also help us control for teachers' relationship with a student, because the teachers don't have any relationships with the student, right? And there's nothing about tone or body language, so maybe it helps us to account for that too. So in the study, the source of explained variation was the inferred race from the vignette student name, black or white, and they did do a follow-up questionnaire asking teachers what race they thought the student was later on in the study to see if they were actually measuring this. And we still do have sources of unexplained variation, right? Like the teacher's skills at behavior management and teaching, we don't really know. Teacher beliefs about discipline, they could have done an exit study about that, but I'm not sure if they did. There's lots of unknown variables. But we're hoping that the randomized assignment is kind of balancing those two groups in terms of having teachers, the mix of the two groups in terms of having teachers of different skill levels in each group. And we don't know for sure, but there's a way that we can kind of quantify sort of how likely it is that those groups are similar. Okay, so this is the data over on slide 17, if you want to join me there. The table down here is just about the troublemaker score. You can see the mean ranking for the teachers who read the vignettes with the white sounding name and the teachers who read the vignettes with the black sounding name. And this was after they had read both vignettes. Over in the graph, just to orient you to it, this is the teachers' rankings for whether they felt troubled by the students' behavior and whether they would recommend disciplinary action. And they were asked 2 times, right? They were asked after they read the first vignette and then after they read the second vignette. The darker columns are for the teachers who read the vignette that had the African-American sounding name, and the lighter columns are the ones for the teachers who read the vignettes with the white sounding name. And so you can see that for teachers reading about with the student with the white sounding name, it's kind of staying the same, right? There's really not much of a difference between the heights of those 2 bars. And the white students are also similar to the teachers who read the vignettes with the white sounding name. They're similar to the teachers who read the vignettes with the African-American sounding name. Like the heights are pretty much the same, within very close to each other. But it's the second infraction where you see a big jump for the African-American students. And this is why it's called the 2 strikes study, because what we see is that it seems like when teachers are working with African-American students, they see misbehavior more as a pattern. And they don't see that for white students. White students are kind of like given this benefit of the doubt that, oh, it's an isolated incident. So that's kind of what the researchers sort of thought was going on. So you can like draw on the graph if you want to take some notes. But I was hoping we could spend a few minutes and just catching up, making sure I'm reading what people are writing. So the thing we could spend a few minutes, just take a minute to sort of consolidate, maybe pick one study, and I'm over on slide 18, maybe pick one study and think about how was it that the study design accounted for different sources of variation? How are we using multivariable thinking to inform our study design? So I'll give you a minute just to sort of process that, maybe write a sentence. And I'll check the chat while you're doing that.
One question in the chat you might want to address, Laura, is a couple of people asked for the Yale study number 2. You have information about the race of the teacher who is responding to the question?
Yeah, so I have a link in the materials that we're going to post on our website. I have a link to the actual report. And so you can, they did report on that. I think they did not have enough of a mix in order to test whether that variable mattered. But they did have teachers of different races. But the report is really easy to read. Like I have my students read it. So, you know, it might be like you give it to students and they can kind of unpack it too. I'll send that along. And then I'm just going to stop share because my screen is frozen. Sorry. I think I was clicking on too many things. And I want to thank folks for whom this might be like a little bit too real, for hanging in there with us. So I just want to say I appreciate you, and I know that it's hard. And I'm trying to get it to show. Okay. So this is the link over on the last slide. There's a link to our website where after the talks, we'll post more information. Like I have full-on lessons that kind of go in more detail about these studies that you can use in your class, ways to connect it to simulation-based inference and other methods, along with the original sources, so you can actually get the kind of juicy details that you want, or have students read real research articles. And this is my email, so if you want to copy it down, I'm happy to be a partner to find more topics that use social justice. I teach intro stats, so there's lots of stuff out there that my students can't really access that use multiple regression and hierarchical linear modeling. So there's plenty of opportunities there. The Civil Rights Data Collection website got a facelift, so if you need help sort of navigating that, I can help with that. If you like Desmos and want to learn more, I can help with that. Or if there's anything else you want to talk about, I'd be happy. Just send me an email. And I guess I'll take questions. I'm gonna put my email in the chat so that I can actually see people's faces. Hi. Oh, there's a cool idea from Beth about giving p-values for an observational study and an experiment and asking students which one has stronger evidence for causation, so that we're thinking about study design and not just what's the number tell me. That's really cool. Yes, Desmos, it's called Desmos Activity Builder, and it is free. And the way that they're funded is that some publishing companies will pay them to integrate it into their textbooks and their online textbooks. So it's free for anybody to make your own slides. It's pretty much the same thing as making PowerPoint slides, but it's better because then you can see what students are thinking, and they can actually write math equations and things like that. So yeah, it's free.
The questions, comments specifically for Laura, and in a bit, we'll throw it open to questions or comments on anything you've seen today. But questions for Laura in particular first?
Some I see are saying, how do I multitask? Is that about like reading students' responses? Yeah. So during class time, I have two computers. One is just what's being projected, and the other one on my laptop, I see all the students' responses. And I take these like super short breaks and like read all the responses that students are giving me and like who's actually on that slide. So it's like a minute. I can read pretty quickly, and I can identify like who needs me to walk over to them and help a little bit. So yeah, I don't multitask so much as like task switch, right? Does that help?
Your class size, Laura, and what kind of environment is it? What kind of classroom?
It's a regular classroom with chairs and rows, because I didn't get on the list early enough for the one with tables. And so it's hard to like get through to the back room because it's really small. We are capped at 25, I think, 25 students. So they are small, but I feel like this might actually be helpful. I've taught bigger classes at other colleges, and I feel like it would be helpful because then you can make sure everybody's on the same page. Like I've taught up to 40 students, which is, I don't know, I think it's too many, but I don't know. We have 75 in here, I think. So I think it can, how many students it can accommodate. I think it can accommodate a lot. You can also, if you have TAs, you can add them and they can, there's like a comment feature in Desmos. So you can, like if students are getting something wrong, I'll like send them a note and be like, oh, actually you have to click here, or no, it's more like this. So if you have TAs, you could add them and they could be like in charge of a set of students and monitoring those students' progress. You can also use it asynchronously. I've done that when I've taught online.
Thank you very much to Laura. Thanks to all presenters today, because we have 17 minutes left for overall Q&A. So thanks to everyone for managing their time so well. If you have any questions, comments, reactions to anything from today, here's your chance.
Maybe
In case
while we're
anyone
waiting
needs
for a
to
few
jump off,
questions.
Yeah, go ahead, please.
I was just going to say, one thing that struck me, Alan, while Todd and Laura were talking, I just thought maybe I draw everybody's attention. Choosing a good context has a lot of complexity to it, right? And you've seen the three different presenters. I mean, we each presented some different data sets. I talked about college tuition, and Todd talked a lot about the COVID data, and Laura, you unpacked a few really rich data sets that explored some complex, sort of social issues and ideas. I think one of the key things I just emphasized to all of you, in contrast maybe to your own experience, like mine as an undergraduate math major, where it seemed like the instructors took some little bit of joy and excitement about giving us data sets that were really hard to think about, right? If we think about, those probability examples where like I got the wrong answer every time because my intuition was wrong. And I think as an undergraduate math major and even as a graduate student, I kind of had enough confidence in my own ability to not let that chase me off from the discipline, right? Oh, I screwed up. My intuition was wrong. You got the wrong answer, because it was a bit of a gotcha moment, right? A little bit of an aha. I think that in contrast, when we're teaching introductory statistics students and even in the intermediate course, most of our students are not math majors or stat majors. Most of them come in with a lot of fear and trepidation about the discipline. So one thing I really like about the college tuition example and about the COVID data and about the examples you showed, Laura, is that I think it sets an expectation for students to feel like, hey, I've got something to offer. I've got some ideas about this data. I've got some ideas about, what these sources of variation are and what's really going on, that then you can leverage as you unpack the concept. And I guess I've just really come to appreciate so much that my teaching of introductory statistics needs to be different than my own experience learning introductory statistics, and sensitive to that. And I really think you can create a classroom environment where the students have a lot to offer. Maybe not on some of the deep statistical concepts right away. That's why we're here, but on the context itself that leads naturally into those. So.
Yeah, I think that's why I chose school discipline too, right? Like you could do wages, you could do anything really, but students have like they are paying attention to the world, which is different from when I was growing up. So they do know about racism, and they know about what detention is, right? So they understand what suspension is. So they already have they don't have to do that heavy lift of like, what is, a salmon going upstream or like something like that.
Do have a question from Haley. So to what extent do we align with our department? That's a great question. I mean, certainly some of our other department members are on this call, so I got to watch what I say. No, that's funny. I think that there are some things that we're definitely trying to sort of emphasize and push, both sort of within our departments, within schools like ours, and at a national and international level. There's no doubt, and that's one reason why we think that faculty development workshops like this are so important, and frankly, why the National Science Foundation has come in and supported this, because they say, look, we do need to move the needle on some of these things. And I guess I'll just go back to some comments I started with earlier today, which, you know, in the first iteration of the GAZE guidelines, multivariable thinking wasn't called out. Then it sort of got there and it wasn't really clear necessarily what it was or how to do it. And that may still even be the case in this latest iteration of GAZE. So I think that there's some importance to these discussions, so that we can, as a community, shape each other sort of moving forward. So I would not say that this is something, some of the stuff you've seen today is necessarily uniformly applied across all people in our departments. That said, I do think that as a national and international group of statistics educators, we do need to be, because GAZE is pushing us there. And so we've kind of agreed, look, multivariable thinking is important. Now the question is, so what does that mean and how do we do it? And so hopefully you're getting some ideas here that you can start sort of bringing into your class. And I'll also say, from that kind of operational and implementation standpoint, what are those one or two things from today that you're going to take with you and try in September or late August? And tomorrow too, but you don't know what's coming tomorrow yet. But I would challenge you, and I'll probably, if you know, at the end of the day tomorrow, somebody can remind you of this. You know, what is the one thing you're going to do? And maybe it isn't sources of variation diagrams every day. Maybe it isn't going all in on sort of, you know, social justice examples through your whole semester. But what is the one thing you're going to do, or the two things you're going to do to start trying out some of these ideas? I really would challenge you to sort of think about that, and then shape them and implement and make them sort of your own as you do it. And that'll push us all in a good way.
Questions or comments? And just to remind you, in case anyone needs to leave soon, we'll do this again tomorrow. Same time, sort of the same place. We'll be on Zoom, of course, but it is a different Zoom link. So somewhere in your inbox, you should have an email message from me giving you a link to today. Obviously, you got that link. And then there's a separate link for tomorrow. I'll probably send another email tonight or early tomorrow to remind you about that. We will post the recording maybe later today, maybe not until early tomorrow, depending on how quickly Zoom gets the recording produced. Let me give you the address in the chat again about where you'll find the slides and data files and recordings and lots of things. Questions, comments, thoughts, other examples, ideas about multivariable thinking you'd like to share? Let me also say, while I'm rambling, that even if you don't teach beyond the intro stat course, I think you'll still find valuable ideas and examples tomorrow. Some of tomorrow's examples will go into a second course in statistics, but there will be a lot that's applicable to first course students as well. Plus, even if you don't teach a second course, it's nice to know what kind of things can be done and are done in the second course while you're teaching an intro course. So please don't be scared away from coming tomorrow because of the bridge to intermediate courses tomorrow.
No, Alan, thanks for saying that. It makes me think too that as you think about implementation in the fall or beyond, one of those questions you might have is, you know, what kind of supports are in place beyond this workshop? And I just want to point out, and I know Alan, you just posted the link to the workshop site. There's other workshop sort of professional development links there, and presentations and resources. There's a link out to other websites that a number of the folks of us who've led this presentation today, the presentations today, have been part of. I'll also point out that one of the things that this NSF grant is also supporting is some of those next steps for implementation. And so while we don't have all the details worked out yet for this fall, stay tuned to your email. We've got your email as you signed up for this. We won't overuse that, but we will reach out periodically and let you know about other upcoming workshops, but also about some mentorship opportunities. We'll call it a mentorship accountability opportunity called our EA Post Scholars Program, where you can commit to trying some of the things you're hearing about in the workshop today or tomorrow, and then get some support from us as presenters and mentors to kind of do that implementation and have some small stipends associated with that. So stay tuned for that. More details forthcoming. But even if you don't participate in that, we just love to hear from you as you're trying things, and we're available to ask questions and point you to resources. So hope that you'll keep that in mind as you contemplate what you heard today and come back tomorrow and think more about what this is going to look like in your classes in the future.
Anyone wants to say, here's your chance. You'll have a chance tomorrow too, but you've got another couple minutes here with the chance.
I appreciate Selma's last comment, and I think that is something that's a great idea. We would love to help with that.
Yeah, and I'll just build on that, Beth, and say that's what we're hoping will happen. And so please let us know how we can assist with that, whether it's just answering questions ahead of time or coming in. I mean, the great thing about Zoom and these kinds of environments, it's very easy for us to come in and just talk for a few minutes about specific context of your department, answer some questions, things like that. We've done that over the years. We also love it when all of you take this and then start, doing your own in-house professional development and things, and we're happy to support and discuss that. Thanks.
I'll turn off the recording here. If you have a question, but you didn't want it to be recorded, you'll have a chance in a moment.